Hi, awesome fourth grade mathematicians. Today we are going to practice converting mixed numbers to fractions greater than a whole. Your families probably call those fractions improper fractions. And then we will also be taking improper fractions or fractions greater than a whole and converting them to mixed numbers. Something that's really important that I know has been confusing a few of you, that is, we are basically writing the same fraction more than one way. We can write fractions in more than one way, the same way that we can write, for example, multiplication problems in more than one way. You all know that 4 times 2 is 8, right? And we also know that 2 times 4 is 8. Okay? You technically also know that we could also say that 2 times 2 first, right? Times 2 is also 8. 2 times 2 is 4. 4 times 2 is 8. So we know that, gosh, here's 1, 2, 3 different ways of writing the same multiplication problem. Well, when we're working with fractions, similarly, there is more than one way for us to write really the same thing. We call them equal. Okay, I'm going to look with you first at this picture model. We see here that we have, first of all, we need to figure out how many parts are in the whole. I have 1, 2, 3, 4, 5, 6. There are 6 parts in that whole. Let's just make sure they all have 6. 1, 2, 3, 4, 5, 6. Oh, 1, 2, 3, 4, 5, 6. So I know that when I'm going to write what this picture is showing as a picture model, when I'm going to write that as a fraction greater than a whole, or what your family calls improper, I know that I need my fraction bar, and I know that the number of parts in the whole is my denominator. That is always true with fractions. So the number of parts in the whole is my denominator. I said that there are 1, 2, 3, 4, 5, 6. In one whole, there are 6, so I'm going to put my denominator as 6. Now, I know that this says greater than a whole, so I know my numerator. I know my top has to be larger than my denominator. So I'm going to try to figure that out right now. I want to know then in my entire picture, not just one whole, but in all 3 of these holes, how many total sixths are colored in, which represents that they are eaten? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Because there are 16 individual sixth units. I remember we learned a unit fraction. There are 16 of those individual units that were eaten. I want to make sure I counted right, so I'm going to check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was 6 times 2, right? I had 6 and 6. 6 times 2, plus, that's 12, plus 13, 14, 15, 16. That is where I got my numerator. How many units were in the whole? To figure out my denominator, I looked at how many is in just one of those holes, and it was 6. Now, this picture model equals and is exactly the same as this fraction greater than a whole. Equal. They now say, all right, we want you to write that exact same fraction one more way. And this time they're telling us the title of our column says mixed number. I know I'm going to have a whole number, and then I know I'm going to have a fraction, because I know that to be a mixed number, you need those 2 things. It's a mixture. I'm going to now break this down and take a look here. I know that this whole number is going to be the number of holes that I have colored in. Well, here is one whole pizza or pie. Here is another whole pizza or pie. And here is 1, 2, 3, 4, 5, 6. There is 1, 2, 3, 4 colored in out of 6. So when I go to write that as a mixed number, I have 1, 2 whole pizzas. That's my whole number. I make it huge, at least 2 times bigger than our fraction to show that it is for sure a whole number. 2 pizzas or pies and 4/6 of another. Okay. Now I use the visual picture model a lot to help me to figure out both of these. There are strategies for how we can convert a mixed number to an improper fraction because they're equal, and then to go the other direction as well. I want to show you that now, and this time we're not going to use this visual model as much to help us, just to show that we can do this in a number of different ways. Okay. If you didn't have a picture model here to help you, and your workbook said you have 16/6, what does that equal as a mixed number? Here is the strategy for figuring that out. Okay. We could flip this. Okay. We could recognize that a fraction is really saying that we have 16/6, and we're going to put those into groups of 6. That is like saying 16 divided by 6. We are going to see how many times can we take 6 out of 16. Okay. When I do the division, which I learned in other units, good thing you all were division rock stars. Okay. 6 does not go into 1. We know if I count by 6s, I'm trying to get close to 16 and not go over 6, 12, 18. Oh, 18's too much. It went over. So 6, 12, 2. 2 is going to be the number I use. After we divide, we multiply. 6 times 2 is 12. Then I subtract. 6 subtract 2 is 4. None left. So I have 6 goes into 16 2 whole times. Oh, check that out. That's why we have that whole 2 there. We have 4 individual parts left over. Go back to your model. Isn't that what we had in our other pie or our other pizza? 4 out of 6. So whatever you have for a remainder when you divide becomes your numerator. Remainder. Our remainder was 4. And then our rule is always denominator stays the same because that shows how many parts were in each whole. So 16/6 is really equal to 2 and 4/6. 2 and 4/6. We divided. We just have to train our brain, okay, that your quotient is the whole number. The remainder becomes your numerator because that represents what's remaining in that other drawing. Okay. And then the denominator stays the same because that's the number of parts in each whole. Now, that's going from fraction greater than a whole or an improper fraction to a mixed number. You all know that we can also go from a mixed number, right, to a fraction greater than a whole. We know one strategy would be to, and a lot of you like to do candy bars, but you could draw your candy bars. You would need 2, and you're going to split them into 6ths. We know we ate all 2 candy bars. Then we know we ate 4 out of 6 of another one. 1, 2, 3, 4. Then we want to know, well, how many total individual 6ths is that? This is 6, 12, 13, 14, 15, 16. That's why that's a 16. And then we know that how many parts are in each whole candy bar, sixths. These really two models show the same thing. But let's say you were going to work on converting. You don't know that number anymore. You don't know the greater than a whole fraction. And we want to convert this without doing a drawing. We know we take our denominator, we multiply that by how many wholes you have. That shows that here. There are 6 in each. You have 2 of those. So without even looking at that, 6 times 2 is 12. Then you have to add these 4 that are left, plus 4. 6 times 2 plus 4. 12 plus 4 is 16. Again, the denominator always stays the same. So as you can see, we can start with a picture model. We can convert it to greater than a whole or mixed number. We can start with a mixed number. We can use strategies for creating greater than a whole, and we can go back and forth between all of these. Many of them will help you to find the other one. We just have to train our brain when we're looking at greater than a whole. How do we make that a mixed number? When we're looking at a mixed number, how do we make that greater than a whole? Next one. I first want to remind myself I'm writing the same fraction 3 different ways. They're all equal. I'm going to make my fraction bar because I know I need it. This is the column that says we're making an improper or a fraction greater than a whole. I know that that tells me the numerator is going to be bigger than the denominator. To figure out the denominator, I look at how many parts are in just one of these wholes, because it's going to be the same for each. Well, this is 1, 2, 3, 4, 5. There's 1, 2, 3, 4, 5. If I wasn't sure, I could check 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, each of them has 5 parts in each whole. Now I want to look at what was shaded in all together. This time, we're looking at all the wholes put together. And we want to know how many individual fifths did we eat? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I ate 12 fifths because every one of these is a fifth. 1 out of 5 parts. Count up all that are shaded in, there's 12 of them. Now, let's write 12 fifths as a mixed number. We just learned that that really means 12 divided by 5. I'm going to count by 5s. I can't go over 12. 5, 10, 15. Oh, 3 is too many. This is 2. 5 times 2 is 10. It is 2 remainder 2. Okay, we have learned that this quotient, that whole 2, represents how many wholes we have in our mixed number. We know the remainder tells us how many units. It's our numerator. And the rule about the denominator, hope you can say it out loud, the denominator stays the... If we want to see if we did that correct, let's go back to our model. How much did we color in? We colored in 1 whole candy bar, 2 whole candy bars, and 2 out of 5 of another one. 2 whole candy bars and 2 fifths of another. To go in the other direction, because we said we can do that, you're going to follow the strategy again, multiply and then add. 2 times 5, that works because look over here, we have 2 5 times. Sorry, we have 5 2 times. 5 times 2 is 10, right? 5, 10. 5 times 2 is 10. Plus the other leftovers, so 5 times 2 is 10, plus 2 more, we will get 12. Denominator stays the same. We know that these match. We have done it correctly. Last one. We could, for the first time, write our mixed number first and then convert to greater than a whole or improper? Let's do it. How many whole cubes are colored in? This whole thing is 4 out of 4, right? Here's 4 out of 4, which equals 1. Here is 1, 2, 3. That must represent 3/4. So we know that we have 1 and 3/4. Now we want to write that as a greater than a whole improper fraction. We would use our strategies. 4 times 1 plus 3. 4 times 1 is 4, plus 3, 4, 5, 6, 7. 7, denominator stays the same. Let's check using our model. In a greater than a whole improper fraction says how many individual pieces did we eat out of the entire drawing? 1, 2, 3, 4, 5, 6, 7. It matches. And then every one of these denominators stay the same. Let's check it with our division. 7 divided by 4. 4 goes into 7. Let's see. 4, 8. Oh, we're already too far. So 2 is too much. Must be 1. Remember, if we didn't have this to look at, how we would come up with this is we would write 1 whole, because that's our quotient. The remainder tells us our numerator. Denominator stays the same. Your assignment today is going to be to complete one of these in a Google Doc. Okay? It will make more sense when you get to that document and you see it. You will find the assignment in your math Google Classroom. Your job will be to look at picture models and try to convert it to both types of fractions today. You can work in any order. So from picture model to mixed, from mixed to greater than a whole, or whatever order you'd like. Okay, please email me if you have questions. Thank you for being good listeners today.